So the lab we're doing today is going to investigate something we kind of already know, we're just trying to prove it. We're looking for the relationship that exists between normal force and friction. Okay? We're going to use that relationship to calculate the coefficient of friction from a normal force versus friction graph. Okay? So all we're trying to do is basically confirm the relationship that exists in this formula here that we've been using already for a few days. Okay? The way we're going to do that is we are going to increase the normal force and measure the corresponding force of friction. Now I say it like that, but it's actually going to be very indirect that we're going to do that. But that's essentially what we're doing. In the end, we're going to build a graph of normal force versus the force of friction. Okay, it'll be like this. And we'll get an equation for the line, the whole bit. And we're going to use that graph to calculate mu. Okay. So the true procedure, and this can help you with your design, okay, is that we are going to use a ramp, okay, like so. Okay, so we're going to have this ramp, and what we're going to do is we are going to put a box full of masses. Well, it won't be full at first, but we're going to put this box on the ramp, and then we're going to tilt the ramp until the box starts to slide. While we're doing that, we're going to be measuring the angle of the ramp using the clinometer on our phone. So if you have an iPhone, okay, the clinometer is in the measuring app. So if you hit measure, okay, it probably comes up with that measuring thing that I still haven't figured out how it works. You're supposed to like find nearby surfaces and do something. It doesn't work. Anyway, go to the level. That's the one you want. Okay? And if you turn it on its side, it tells you the angle. Like this is nice and level right now. Okay? So what you're going to do is you're going to be, I can't see it, you guys can see it, okay? But I'm going to lift slowly the ramp. And as soon as that thing starts to slide, that's the angle I need to record. Okay? Now, I was able to collect this data once I figured it out, okay, by myself. So your group should have no problem coordinating this. Okay? You got one person lifting, one person watching the clinometer and getting the data. Okay? So it's pretty easy. There's not much to it, okay, in getting good data for this lab. Now, when we start out, okay, in this, before we even get to the rest of the procedure. So that helps you with your design. Think of a couple of things here in terms of controlled variables. Okay, we're measuring here the angle, but we're using that angle. We're using that angle to get both the normal force and the force of friction. Okay, so what's happening in the lab is this. Okay, we're creating an inclined plane, and we're creating a situation where the force of static friction is equal to the force parallel. Okay, that's why we're recording the angle when it just starts to slide. When it just starts to slide, that means that static friction was at its maximum at that moment. Okay, and then it started to slide. So when that's true, then that means the force up the ramp and the force down the ramp are the same. They're equal. The net force is 0 because it's not moving. When it just starts to move, okay, it's slightly more, but that'll be kind of our point of measurement is that point. Is everyone okay with that idea? Okay, so we're recording this, but we're using it to get the two forces we want. This one and this one. Okay, so we're going to measure theta the force of gravity will always be easy to calculate because we'll know what our mass is, and we'll just go mass times the force of gravity. And then we'll calculate F parallel, which will be equal to our force of friction, and we'll calculate normal force, okay, for each trial. But all you're going to measure on each trial is the mass and the angle. That's the data you're going to collect. In the analysis is where you'll do all this calculating. Okay? Everybody good with that? Okay. So for our hypothesis, if we're going back to that, okay, for our hypothesis, the if part of our hypothesis needs to talk about the relationship that that formula says exists. Okay? That there's a linear relationship between those two things. And the and part is, as always, going to describe the experiment, okay? Like a sled or a box will have its mass increased and the angle be measured and blah, blah, whatever, okay? Whatever you want to say about the experiment, okay? And then the then part needs to tell me, how will you calculate mu from this graph? Okay? How will you calculate mu from this graph? Is everybody with me so far? Okay, so let's kind of think about our data and what it should look like, because that's what I screwed up this morning. I don't know why I had this thing in my head, but I'm a very linear thinker, okay? And when I get an idea in my head, it's very hard to like turn my head another way, okay? So I had this idea in my head that as I add more mass, what should happen to the angle? Yeah, I had in my head that the angle should increase as I add more mass to the cart or to the sled. That's not at all what happens. In fact, it goes the other way sometimes. Okay? The angle actually is, it varies a little, but it doesn't really have a trend per se. Okay? It changes a little bit, but it doesn't really have a trend, because as I increase the mass of this sled, friction increases, for sure. But what else increases?
F parallel.
F parallel. Okay, and that's what I just didn't know. I didn't have that in my head this morning, just wasn't thinking straight. And I kept thinking, something's wrong because the angle's not getting bigger. It's okay if the angle doesn't get bigger. It's okay if the angle stays the same. It's okay if the angle gets smaller. Okay? It's going to kind of do a lot of things. It's all right if it does that. All you're going to need to worry about is, once your calculations are done, does friction increase with normal force? And it will. It does. I graphed my data. It worked perfectly. Okay? It'll work perfectly for you. So don't doubt the data you get. That was my problem this morning. Everything was working as it should because it's physics and it always works. I wasn't thinking straight about what should have been happening. Okay? So don't make a mistake. Really, really embarrassing to have a major screw up like that. Okay, for a physics teacher. All right. Everybody okay with what they're going to do here? Okay, lifting the ramp, putting more mass in. So for our trials, okay, this is the data you're going to fill in. Okay, what you're going to do for your trials is, your first trial is just going to be the box and the plastic thing inside. You're going to take out all the masses. Put it on the ramp, lift up the ramp until it starts to slide, record the angle. Okay? Then you are going to add all of the small masses and these two here at the top. Okay, so all the small masses and these two masses. Put it on the sled, or put it on the ramp, record the angle. Next trial, add this one. Okay, do it again. Next trial, this one. Do it again. Last trial. this has another friction sled in it. Okay, you're going to flop it on top. What do you need to know about all of these things? Yeah, their mass. You need to know their mass. So really all you need to know is the mass of this thing, because you're putting it all on at once. So just set it on the scale and get its mass with everything in it. Okay? You need to know the mass of the box and the plastic thing by themselves. Put that on there, because all of these are labeled. Okay? You can just add as you put on. You don't have to like put them in and put it back on the scale. Okay, and then put another one and put it back on the scale. You guys can add. Okay? All right? Everybody follow. All right, we'll talk about what we do with the data once you have it. Okay? So, go. Hopefully now you have this chart filled in. Okay, so you've got your masses for each trial, and then you've got the ramp angle upon sliding that you recorded, okay, while you were tilting the ramp. Now, we're going to use the instructions in the procedure to calculate the stuff we need to actually do the analysis, which is the next chart in your lab report, because there's two charts in there. Okay, so we want to calculate the normal force for each trial using Fn equals Fg times the cos of theta. In other words, this triangle right here. We're going to calculate Fg for each trial by taking the mass, multiplying by 9.81, and then we're going to take that number and multiply by the cos of theta to get normal force, because it's the adjacent side. We're going to do a similar thing to calculate F parallel, except instead of using cos, we're going to use sine. You guys know how to calculate the sides of this triangle. You just have to do it for each trial. So calculate the force of gravity, normal force, and parallel force for each trial, and you will have this one filled in. It is this chart that you're going to use to build your graph. You're only going to use these columns. Okay? You don't need this one to do the graph. Okay, so what you're going to do, I think I have it here. Okay, so I had my data filled in. Okay, so I've got, this is my normal force. Okay, this is my force of friction, okay, that I already calculated. Notice I didn't put any newtons in here. The newtons are in the top one. If I put letters in with these numbers, Google Sheets will freak out. Okay? It doesn't know what to do if there's letters beside numbers. Okay? So we're just going to highlight all of that, copy it, and paste it into Google Sheets. Okay, so I just pasted it in. It looked like that, and then I just built a chart for it. Okay? I built the line graph, which ends up looking pretty linear. My last 2 points are one above and one below, but they're still generally going the way that they're supposed to go. Okay, I got an equation for the line, and I can use that equation of the line for my coefficient of friction. It's there somewhere. We just need to figure out how to get it. So for the analysis, if you look at the lab, okay, there's no questions. This is it. This chart and then this little blurb here. It says, include your graph here, so put your graph in here, along with your calculations of the coefficient of static friction. So all I want to see here is one thing. You only have to do one thing here to show me the coefficient of friction from your graph. Okay? What I don't want to see is 5 calculations of FF divided by FN equals this. That's not what we're doing. We're using the graph, not the data. Okay? One calculation is all I should see here along with your graph. So you got a pretty quick analysis. Build the graph and show me how you calculated it, and you're done. You don't have to write anything. Okay? Just do that. Okay, for your conclusion, same as always, copy paste your hypothesis, and then did you see a linear relationship? Were you able to calculate the coefficient of friction? Accept or reject. And then sources of error. Okay. Anything that could have affected the force of friction, needs to be looked at in terms of, was there any sources of error here? Okay, so when you were doing this lab, what were some of your sources of error? Okay, and how would you fix them? You need to. Right? Any questions on that? Okay.